Hello and welcome to this GDS BES tutorial video 3.1 Advanced Settings. Now, the BES software provides several signal processing settings to improve the accuracy and interpretation of the data. These settings allow the user to correct inversion issues, adjust data capture settings, and filter unwanted background noise. The following functions are particularly useful when acquiring and processing P-wave and S-wave signals. We have the signal inversion, we have the acquisition settings, and we have the filter parameters. For the signal inversion, during testing, the received waveforms may not always be in phase with the transmitted signals. This occurs because the orientation of the top cat and pedestal elements is not visually obvious, which may lead to a 180 phase mismatch between the transmitter and receiver. So what signal inversion allows the user to do is to flip the received signal vertically so that the transmitted and received waveforms align. This makes it easier to identify peaks and improves consistency in data interpretation. So this works by when a signal is inverted when you tick it, the peaks and troughs are swapped, so the positive values become negative and vice versa. Then the corrected waveform should display both transmitted and received signal peaks in the positive portion of the graph, simplifying comparison. So when would you use this? You would use this to apply inversion when the received signal appears to move in the opposite direction to the transmitted wave, or when the first arrival peak is negative instead of positive. For S-waves, inverting ensures that the up-down-up cycle is displayed correctly, and for P-waves, the same method applies if the signal is reversed relative to the transmitter. Moving on to acquisition settings. Now, the acquisition settings control how data is recorded by the system. Two main parameters must be defined. Acquisition duration, which defines the total time window in milliseconds during which the system records data. For example, a duration of 5 milliseconds provides a short capture window, while 20 milliseconds allows longer signals or multiple cycles to be observed. Choosing a longer duration may be useful for low frequency signals, but can increase file size and processing time. Then, requested sample rate. This defines how many samples per second are taken by the system, expressed in thousands of samples per second. For example, 500 equals 500,000 samples per second, and 125,000 equals 125 million samples per second. A higher sample rate captures more detail in the waveform, which is useful for high frequency signals, but also increases the data size. So the best advice we would suggest is to use a shorter acquisition duration for high frequency signals where only a few cycles are needed. Use a longer acquisition duration for slower waveforms or when viewing multiple cycles, and select a sample rate that is at least 2 to 5 times higher than the highest frequency of interest. This is to ensure accurate representation. Now, the last one, filter parameters. Filters can be applied to reduce unwanted background noise from recorded signals. For filter received data, this option applies a frequency filter to the received signal, removing low frequency interference. A common example is 50 Hz mains noise from electrical equipment. And you have the cutoff frequency. The user must define a frequency threshold in Hertz. Frequency below the cutoff are reduced or removed, while frequencies above the cutoff are retained. The cutoff should be set several times higher than the dominant test frequency to avoid distorting the actual signal. For example, if testing involves signals of around 5 to 10 Hz, setting a cutoff at 20 Hz will effectively suppress 50 Hz background noise without affecting the measured data. Please note that filtering should be used with caution, as overfiltering can reduce genuine signal detail. So to summarise, these BES functions enable precise control over signal presentation and data acquisition. The signal inversion corrects for reverse transducer orientation by flipping the waveform. Acquisition settings define both the time window of the data and the detail level via sample rates. And filter parameters reduce unwanted low frequency interference, such as mains noise, while preserving the primary test signal. Okay, that is the end of the video. Thank you so much for watching. This has been 3.1 Advanced Settings. Thank you.